Right, I guess let's kick this off. The last session of the last day. I am surprised there are people in the room. So, well, first and foremost, thank you for being here. And it's been a privilege to actually have somebody come in. Means you really do want to hear this. Kind of interested in this. All right, so by the way of interest, my name is auth. I am a security specialist architect with Amazon Web Services. And prior to joining AWS, I spent 8 years in management consulting, doing their internal IT systems and architecture and design. They didn't let me out much. And 15 years before that, I spent on Wall Street working for the financials. They let me out even less. So joining AWS, one of the exciting things for me was that I get to work with customers like yourselves, customers that sometimes ask questions, and sometimes those questions are easy. Let's read this documentation or look up that blog. Sometimes, though, those become head-scratchers. And what I wanted to talk today is one of those head-scratching cases where the customer asked, well, how can we do this? We had to go through the process of figuring out, well, what the actual problem is, what the solution is, how can we deliver on the right outcomes, then how we can get the stuff deployed. And throughout the session, so it's real customer use case, and then I'll close this off with a demo, some frequently asked questions, and maybe a Q&A session if we have some time. And so for the challenges, what have we seen here? Right. This is all about the navigation. So in the typical world, when you come in and you authenticate to your IdP, one of the things that happens is your IdP sends you off to a portal of some type. And now you're on that portal, and you need to find your app. You need to navigate through the endless menus. You need to know where to go, how to get there, which options to select, and potentially what is it that you're going to provide to the application, what kind of parameters you need to specify. The answer to that friction is deep linking. And our IdPs can deep link. We do have things like URLs that we can pass back to the service providers. Unfortunately, not all of the IdPs are capable of creating a conditional link. A conditional link being a link dependent on the profile of the user that's currently trying to get in. Right? So from the federated identity perspective, we all kind of know this, right? We've got RelayState. And in some of the IdPs, the RelayState is static. So you configure your application within the IdP. You can specify the attributes, and many of those are dynamic in nature. And then you specify the RelayState, and the RelayState is one. We could create a whole bunch of those applications, but that now becomes a little bit difficult. This is how do you manage all those things, right? And a single static RelayState does not lend itself well in a scenario where you have users that need to do different things on different days. So today, your user might be doing one thing, and tomorrow, assume a different security context, maybe work in the context of a different security group. So how do you manage that? So from the RelayState perspective, the acquisition of the RelayState, ideally, your IdP should be doing this. If you have an option and your IdP can do this, great, go with it. If you can't, your portal should be able to do this. Presumably, your portal already knows who you are by the time you got there. Maybe your ticketing system has an understanding of what project or ticket you're working on. Again, use that if you can. Now, if the first two options don't work, one of the solutions here is you have to develop something custom. And this could be a custom app on the internet, or it could be a custom application that you integrate with your portal. Right? And this is all about supplying the RelayState, and this is really what this talk is about. I promised the real customer example. So let's just kind of dive into this and see what the customer environment is. So I've got a call from one of my fellow SAs. What kind of a question? Author says we have a customer that has many support agents, customer support agents. This is a call center customer. And these many support agents authenticate to Okta. And that works great. Now, on their daily lives, what they're doing is they're working in support of many different customers. and they're using Amazon Connect for the purpose. So now the idea here is imagine your day as a call center agent. You walk in, you log in, you go into the portal, you click the button, you log in, and then you end up with this wall of text of different Amazon Connect instances. That's not good customer service. That's not good experience for your users. Now imagine if you have 100 of those Connect instances, hundreds of those Connect instances. You have thousands and tens of thousands of support agents. And all of those are supporting just as many customers of theirs. It becomes an administrative nightmare. And as a user now, you're becoming frustrated every time you're going in. You need to figure out which app you're going, which customer you're supporting today. It's difficult. Right? So kind of the idea here was, well, what can we possibly do? And the answer is, well, why don't we integrate this into the portal? But the customer's portal did not support this. All right. So what else can we do? And this is where we looked at it and said, well, maybe we should dive a little bit deeper, figure out what the actual process is, what the flow looks like, and then from that point on, well, let's figure out what the right solution here. But most of you should be familiar with this, so I'll just kind of run through this, given what this conference is, right? You have, under normal conditions, your SAML flow is your user is requesting an application. This is IdP-initiated auth. Your IdP responds back with a credential challenge. Your user goes through the process, gets the credentials together, authenticates by whichever means necessary. The IdP now is pretty certain it's talking to the right individual. Your IdP now goes over to its local data store, pulls out some data, packages that data into a claim, attributes, and sends this assertion back to the user with the RelayState. Now this RelayState is custom defined on per single application. It's a static value. So your client now goes over to the service endpoint. Service endpoint does its work, comes back, validates the RelayState. If everything is good, your service endpoint now turns around, redirects the browser over to the actual application. This is a great model. It's been working for years. The only challenge is it's working for one individual application, right? So it's not to say all IdPs are working this way. Some do. And hopefully some people in the room that are listening here. So the connection, so how can you actually solve this? Right? We could potentially create multiple applications within your IdP and send users over there. Right? Does it solve anything? And the answer is probably not, because all you've done, you've moved the problem from your service provider side onto your identity provider side. A user still needs to log in, find the right application, select the right application, and then go in. It's an administrative nightmare. Now, from the administrator's perspective, it would be really cool if we could have programmatic definition of the RelayState. Yeah, hopefully somebody's listening. So we looked at the process and we kind of said, well, what is it that we could do here? Is there a way we can inject ourselves and inject user opinion of where they should be going into the process? And the answer is yes, we could. So we've decided to add a couple of additional components here. And there's a logic processor and this UI component in the middle. You could use one or both, depending on your use case. But the idea here is this isn't, I used AWS for development. It was easy for me. I worked there. But these components are not dependent on a specific provider. They just tap into the existing architecture. So here, what happens is you have kind of an easy flow, right? So in the beginning, same thing. Your user is creating a request. Your identity provider is generating a response. Your user goes through the same cycle. We haven't changed anything yet. Right? It's at step number 3 now that interesting things begin to happen on the IdP's end. Because your IdP now can reach into its underlying directory and pull additional profile data that will help you later on make a decision on what to do with where to send the user to. Okta, for example, has great expression language. That expression language can go into the directory and pull out, and in my example, I'm using it for security groups. Just gets the list out. You can get additional attributes. Super flexible thing. So now we package that and we send it back to the user. So we now have an assertion that we use as a proof that it came from the verified source, but secondly, it has additional data in it. We just overloaded the assertion with this security group data or attributes or whatever makes sense for you to make a decision on a profile basis to create the right deep link. So this user now turns around and sends this back to our logic processor. Now, how did it get there? The IDP sent it there. So the ACS, the assertion consumer URL, is pointing to your logic processor. Now, that logic processor is your code. It's under your control. It runs your logic. What could you possibly do there? Anything you want. But you can turn around and go query your internal system. You can just disassemble this SAML assertion, extract the information that you need, repackage it, and do something with it. Right? Again, this is completely 100% under your control. You've just extended the ADP flow with this. But in my case, what I've decided to do is instead of redirecting and creating a service provider initiated request right out of a logic processor, I said, well, maybe we also need some additional user input on this. Maybe the information that is being supplied, that we can supply through the automated means, isn't enough. In a more complicated case, let's get this individual involved. So we're sending this package back to the individual. This browser now gets it. And browser turns around, and now this is a redirect, and we're sending this data over to the user interface. And what happens at the user interface level? The user is now manipulating the data to create a service provider initiated request. That's really what's happening in there. They can pick the right security groups they're working in. They can pick the right URL that they need to go to. They can pick the right application. And that UI combined together with the processor, they both now have the context of a user profile. Why? Because this happened post-authentication. So now that we have the profile in place, the next thing that we're doing is we're making this request back to the IDP. Now, your IDP at this point has an authenticated session from the first 3 steps. And what that allows you to do, it allows for this transition to be seamless. In my demo, I'll show you hopefully, I'll show you the trace. And you will see that there is a secondary request here now going to the IDP. IDP goes through the authentication cycle, authenticates the session, and then ships the SAML assertion back to the user. Now, with the correct relay state, with correct ACS URL. And then now your browser follows the traditional path, and that path leads it to the service provider. Service provider verifies the relay state, verifies the assertion, verifies the signatures, does all that needs to be done, and then the browser now faithfully drops into the correct application. Right, so that's from the architectural side. So somebody was taking pictures, I think. Just flip back. So from the kind of design side, we pulled this together, put a small POC, and then I bounced this off of my colleagues with, hey, does this make any sense? Like, can you see any gaps? What kind of questions do you have before we brought this to the customer? And then we work with the customer, and I think that it's running in production now. So some questions that came up were, well, what kind of business logic could you possibly implement in the processor? And the answer is any. You can build anything you want. It is your code. It is your language. It is your business logic. It might or may not have access to your internal resources. That depends if you need it. You can pass certain data out of your IDP, and maybe you need to go and consult with your internal ticketing system. Well, in that case, that logic probably should reach in. If not, maybe you would just repackage the security groups as I do in my demo, and you can select based on the security group affiliation. You can get the right mapping between that and the target relay state. And then for the compute, what kind of infrastructure do we need to have this? Well, the answer is you need some type of a compute, and you need some type of a UI host in place, maybe, if you are using the UI. Right, so then I brought this to my security peers. And from the security side, we've had a couple of more pointed questions. Like, well, does this thing require any privileged access? The answer is no, not the way we designed this. All this does, if you kind of think about this, it works on the output of your SAML assertion, of your IDP with a SAML assertion. It parses it. And then it uses the UI, and it uses this processing pre-programmed language, pre-programmed function to actually figure out what the right service provider initiated request should be. And that potentially can allow a user to get involved in constructing that. And so now there's really nothing in there unless you choose to put it in. Right? So no privileged access to resources. Now what happens if the request is malformed, right? And the common question is, we're developing this UI page. Our developers are not security professionals. IDPs exist there for a reason. They've been hardened. So what happens there? The answer is, again, unless you put privileged access into those functions, nothing really. Because all you're doing, you're creating a service provider initiated request before you ship this off to the IDP. Now, would this work combined, where you create a UI or you trigger service provider initiated request somewhere from the portal? And the answer is yes. The same thing would work in both places. So you don't need to recreate the application. Right, and then can replays be done? Well, we all know the answers to those questions. You have the audience restriction value, and that initially it's your logic processor that's the audience. Okay. Now going into the demo, and before I jump into that, I just wanted to show the architecture quickly. So from the component level perspective here, again, I built this on AWS because I could and because it's something that I have access to. It works anywhere. So we've got Active Directory that houses users. We've got Okta that those users are replicated into. We have the API gateway for the function. We have an S3 bucket for static hosting. And then we use Lambda for processing, and we use CloudFront for, which is our CDN, to distribute the website. And of course, we have a user in between that bounces throughout against all the services in a manner that I talked about before. And so with that, let me attempt the impossible and swap screens here. All right, so we got this one. All right, so I've got two different screens. One of them on the left-hand side is my demo app. I'm just going to refresh this, if it works. And then on the right-hand side here, I have SAML Tracer. I'm not really sure how well it's going to come up for the cameras, but if anybody wants to talk about this later or a closer demo, I can run through it again. All right, so what we're going to do here is run Okta application, which is effectively what this does. It triggers an IDP-initiated request. We're going to plug in with credentials. And I did disable MFA in hopes that demo gods will be nice to me. I can actually get through this. All right. And what happened here, so let me just see if this is legible, sort of. So what happened here is, and you can kind of see I'm making an initial request. This is where I'm authenticated to Okta. And Okta is using this custom logic processor. It's redirecting the request over there. In there, you have code that processed this SAML assertion. It unpacked it, validated the signature, extracted the XML from within, parsed that data together, and then in the next statement here, it redirected this over to this page with groups, and that's what I'm using for my demo parameters, with groups as a data chunk that would allow us to drive this UI. So this stuff here, alphabet soup, is what the web page received. Now this is a base 64 compressed encoded value, so if we were to decode this, we'll get this demo user is a member of two groups. Now what happens now is we're allowing this user to manipulate this service provider initiated request. So my logic processors also included a map between a user group and a potential relay state, which would be, in our previous customer's example, a long link to where the Amazon Connect instance is actually located. So by changing my group affiliation on the UI, I'm changing my relay state. So in this particular case, let's choose one, and then we're just jumping into the console. Right? And we are now within the EC2 console here. And if we kind of look at it, this is where we were going, and this is where we have arrived to. And on the console here, on the tracer, you can see what actually happened, right? So this was the original request. This section is us requesting a specific URL and specific ACS, and this is where we're actually doing the redirect, right? So what this shows now is how we can use this profile data stored on the IDP to actually send your user to a place where they likely be happier than browsing through your portal and looking for their application. Right? And then just as a secondary demo, yeah, right? Pick something different. And again, we now ended up in a different location. Right? So just by using my custom UI, I just ended up someplace else. All right, so I think this is it for the demo here. Let's just jump back into the presentation. All right. I click the wrong button here, but all right. So what have we done, right? If we kind of think about this, this is a demo of how you can have a user go to your IDP with their existing credentials and get to a specific service based on their security groups without changes to your IDP, and just by you building an extension to it and effectively extending the IDP flow. Now, one thing I know I mentioned a couple times, I built this with Okta and AWS because those are the things that I've had access to. This architecture will work across the board. So on that note, thank you very much. I appreciate your time. My credentials are up there, my work address. The QR code will lead to my LinkedIn, so feel free to connect. And thank you. I have, I think, a few minutes if anybody wants to talk about anything.
Just to be sure, like, if SP initiated supported by the application, by the service provider and the IDP, you don't have to worry about this, right?
Correct.
Okay.
Yeah, so I haven't seen an IDP that doesn't support SP-initiated request unless you explicitly disable it somewhere on the inside.
How do you formulate the, like, because a lot of times whatever's in the relay state could be pretty complicated or ephemeral or this is some weird string. How could you possibly know about that if it's just looking for some blob like that?
Right. So the question was, how do we formulate the relay state and how do we make it into a correct string? So because the thing could be complicated depending on where it's in. Did I get this right? Yeah. Right. So the answer here is your business logic, the one that you've implemented inside of your processing, this function that runs outside of the IDP, combined potentially with your UI, is the thing that's constructing it. So if you think about this, your business processing function, the logic processing end, it has all the data that it needs. It either receives that data from your IDP together with a SAML assertion where you include your profile, or you can go out and get this from that function from your internal system.
Okay, so the application has to be touching that relay state builder.
Correct. So it depends on what you're doing, right? So if, like me, you're just doing a reasonably simple mapping between a security group and a destination, you can probably do it just without touching any internal systems. If you are running an environment where you have, let's say it's based off of tickets, right? And you have a particular security group and a particular system that security group relates to, and you need to go and query ticketing system to drop you into the right application. No, yeah, then you need some type of backend access. All right, well, on this note, I guess we'll close this off. Thank you very much for coming. Thank you very much for staying. Again, last session, last day, everybody's doing airport runs. So thank you again.